So thanks ever so much for joining. This is our webinar for Ultis and NDTkit RT, automatic defect recognition. My name's Matthew Day. I'm the technical sales manager for the UK, and I'm joined by my colleague online, who's based in our Toulouse office, Safir Lazar. He's the product owner for the NDTkit product range. So I'll do a brief introduction to the equipment and the software, and then I'll pass the reins over to Safir, and he'll take us through a demonstration of both products for ultrasonic and radiography as well. Okay. A little bit of history on the product line itself. So back in the 2000, when Airbus was in the throes of putting together the A350, there was a clear need for a system that could manage the workload and feed information into Airbus from Tier 1 and Tier 2 suppliers for scan data and results for composite parts. So Ultis, developed by the Airbus group and supported very much by Testia, was first created and released to market in 2000. Following that, in 2018, after several years of development, we expanded the automatic defect recognition to include radiography, which NDTkit RT was born. Those two product lines almost ran separately, and then in the latter half of 2019 and through this year in 2020, we're merging the two product lines, and we'll be rebranding Ultis as NDTkit UT. So throughout the presentation, I'll make reference to Ultis, but they are both one and the same. NDTkit UT and Ultis are the same product. And by the end of 2020 is when we'll see the full merger of the two products, and the creation of the NDT product line will take effect. So, as I said, Ultis is migrating over to NDTkit UT. Within the Airbus world, it's always been known as NDTkit UT, but Ultis is its commercial name outside of was its commercial name outside of the Airbus group. And as I said before, it will be joining the radiography software program to form the NDTkit family of products. Sorry, one moment, we just have a technical problem there. There we go. Okay, so NDTkit, a new inspection approach. So the context, where did it come from? So many suppliers back in year 2000 and before are supplying elementary parts into the A350 developmental program and live manufacturing program. So at peak production, Airbus was creating 13 aircrafts a month. In total, that requires 11,500 parts to be created and inspected each month. So where did we find ourselves? There are multiple manufacturers, all of different scanning equipment with different data files, provided a very diverse range of results being supplied up the food chain. And as with most industries, NDT was creating a bottleneck for production. So the solution was decided to create a post-processing software that combines multiple data file sources to create one output. This automated capabilities to increase throughput. It harmonized results from multiple suppliers and to provide a uniform result into Airbus. This allowed for it also allows for manual post-processing as well. So the system doesn't have to be driven by an automated scanning rig. Data files can be loaded in from your chosen piece of equipment. And it's design a bespoke automated process, fully customizable by the user, and that bit is key. Okay, so alleviating the bottleneck. How do we alleviate the bottleneck? So if we take a look at ultrasonics first, okay, so first and foremost is to have a customizable view for all scan views, A, B, C, S scans, for example. So completely customizable and can be interpreted by the user. We have complete A scan interrogation. We can also superimpose data files onto CAD images as well, and we can have a 3D rotation of parts. And more importantly, we can create a process, save a process, and have it repeat automatically. And Safia will be able to expand a little bit more on this, but as far as processes goes, there are almost no limits to the amount of different processes that you can save. Because there's a lot of manufacturers out in the industry, it was key that we were able to work with multiple suppliers. So we're compatible with the data file formats for Olympus, Arriva, GE, M2M, Sonatest, USL, Technotom, Sepna, and Logisonic. Because of our connections within the industry, the most recent party to join this list has been USL. Not averse to dealing with companies and having their scan data file formatting adding to our process already. So if we come across to RT, radiography is slightly different. We're not required to use specific file data formatting, but so just like UT, the interface is harmonized across all of the kit platforms. So many of the menu functions and features are a direct read across from one software to another. If you learn how to use one software, then the other one will be just as easy for you to navigate through. Automatic IQI checking. So part of the process is the software being able to recognize features within the IQI tabs. Full image analysis of the instrument. So I don't know, sorry, of the part. So the image might be a little unclear here, but we can draw data lines across our part, and we get cross-sectional areas for both X and Y axis. And measurement capabilities. So we're able to highlight certain areas and pick on and interrogate certain parts. And again, the whole process is designed so that we can create, save, and repeat automated processes for your production line. Compatible with, so it's actually compatible with all standard imaging formatting. So there is no specific data files required for this, and there are very little limitations. Any limitations that are found can be dealt with by the product team. Okay. So looking at added cost versus added value. So this is an investment. We're aware of that, but how does it help you as a company? So if we're looking at added cost, so manpower, processing, repeat inspections, increased job length, reporting becomes an additional activity. in its own right, culminating in additional cost. Apologies, it says revenue there. But if we look at value added time, we have, by using the NDTkit product range, we're looking at reduced inspection time on high volume parts, shorter lead times for parts to reach your end client, quicker response times, and faster solutions as well. Okay, so I'm going to pass over to Sophia, who's going to take us through the two products. We'll be looking at ultrasonics first, and then we'll be looking at radiography shortly after that.
Thank you, Matthew.
No problem, Sophia. I'll just pass you as the presenter. Okay, Sophia, thank you very much, and over to you.
Share my screen. Okay. Can you see this?
Yes.
Okay. So I will start with the demonstration. So at first I will start by load an UT file in amplitude and also in time of flight. So for example, I will open two UT files. Okay. So as you can see, there are many formats like Matthew said, like Olympus, Dr. Hilger, NuScan, etc. It's all UT file. And there are many formats, and we can add also new format if you are interested. So at first I will manage with unit. So for example, you can change, of course, unit microsecond to nanosecond, millimeter or some ply if you have to deal with laminate. And for amplitude, you can change unit between percentage or dB. So I will present some feature of ULTs. For example, at first we can present a duplication. So if you have a cartography, you can duplicate it. And so you can work on one cartography and save the other cartography as a reference. So as you can see here, when I zoom with my mouse, all the cartography are connected. So it's an option. You can associate cartography. So here, for example, no association. So if I zoom on my cartography, the other will not change. And the other side, you can make some association or customized association, and all the cartography will be linked. So it can be useful for time saving and to manage many cartography. I will present some other feature. So for example, we will deal with edge effect correction. So I open the cartography. So sometime in your cartography, you can have some problem on the limit of your part. So there is some feature in ULTIS to manage this problem. So at first, for example, edge effect correction. So you can apply some algorithm to deal with the limit of your part and delete the limitation part problems. Another feature, for example, you have what we call matching. So sometimes if you have many cartography, one can have change during the processing. So I will open to cartography. He's coming. Okay. And so here you can see there is the same cartography, but one is a little bit rotated. So there is some algorithm to deal with this problem. So what we call automatic matching. So you call the algorithm, specify some parameters. And as you can see, the first cartography is a little bit rotated to match the second cartography. Some other cool feature is named calculator. So I will open some cartography. Okay, this cartography, for example. Sometimes you want to make some arithmetic calculation between cartography, for example, subtraction, normalization. So it's possible with ULTIS. So we call what we call calculator. So we can create or load some formula. So let's call this formula. It's just an txt file with some specific syntaxes. So at first the result cartography with the specific unit, and then you can put your calculation. So here it's just a simple subtraction between the two cartography. So I will apply, select my cartography, and then the result cartography here on the left is a simple result between the subtraction between the first cartography and the second cartography. So keep in mind you can create what formula you want, but normally we use some subtraction, addition, or normalization, and you can deal with this feature. So as you can see, there is a palette in here. So if you have some specific palette in your company, you can create some palette. For example, here I will create a palette with, I don't know, for example, 10 colors. So here you select what color you want, etc., and you can create it. And other thing, you can have loading palette. So we create for aerospace, aerostructure, for metallurgy specific palette, and you can select one and, for example, specific red, and load it. So keep in mind you can create or load palette. The palette can be compressed to highlight some defect or slide to the part. The palette can be also, we can also change the value of the palette and modify the limit for the minimum and the maximum. So I present the palette. Now I can show you some selection. So in ULTIS you can create selection like, for example, rectangle, circle, etc. And some strange, I don't know, selection if you want. And you can move them and also show some information. For example, you have geometrical information. So you can have some specific value like the minimum, the surface, the rotation of your selection, and also some statistical information. Show you another one. Here is coming. So you have at the same side the geometrical information and the statistical information. So here, for example, the minimum value of your selection, the mean and the median value, and also the area in a square millimeter. So in UTIS, you can have also some other kind of selection, what we call mask. So for example, I will create a rectangle mask, and with this mask, you can apply it, and you have two options, like keep what is inside the mask or what is outside the mask. So for example, I will apply the mask on the current C-scan, and all the data inside the mask is deleted. You can also apply, for example, the invert mask, what we call opposite mask, sorry, and in the current C-scan, and what is outside the mask will be deleted. So if you want to select a specific side of your part, it's possible with this specific feature. And the third kind of selection, it's what we call a layout. So you can put a specific text, for example, I don't know, part 1 with defect, for example. and apply it. So you can put some layout and with all the selection, and keep in mind all the selection can have some level. So for example, if you want, I will create another one to, sorry, just 1 minute. So if you want to create some level, for example, here this selection will have level 1 and another selection can have level 2. It's useful to separate some kind of selection. If, for example, in level 1 you can put all your selection with defect, and level 2 all the part with no defect, etc. It's also possible. So I show you some selection, mask, and layout with all the statistical and geometrical information. Now I will deal with A-scan. So I will open an A-scan. So at the beginning, each A-scan is associated to a C-scan. So you can calculate the C-scan here with this option. So it's a little bit laggy. Just let me restart the ULTIS. So for each A-scan and each C-scan, they are associated. So you can, when you move on your C-scan, you also move your A-scan, and you can apply some specific gate. So I will show you. So I will reopen the A-scan and then generate the C-scan. Here is coming. So you can see when I move my cursor on the C-scan, the A-scan is directly changing. So when you have your A-scan, you can manage with it with some specific gate. So here, for example, there is a gate 1 in blue. You can add many gate as you want. So for example, I add two gate 2 and gate 3. You can move it and go on a peak. And if you want, for example, in the first echo. And for each gate, you can manage the start of the gate, the width, and the end, and also change the amplitude directly on the A-scan or directly on the parameters. For example, here I apply 10%, and for each gain you can specify which option you want. So for example, in gate 3, I put first peak, so it will detect the first peak of my echo. If you want, you can change it and put the maximum of your gate, and it will directly change on the A-scan and show you the maximum of the peak. So when you have all the gate, you can manage with the gain and apply some gain. For example, I will apply, I don't know, 10%. So my A-scan is directly increasing. Like an UT engine, you can manage with the gain. So now I will just show you, for example, some B-scan. So I will close this one. So in the A-scan menu, you can put some configuration and load some parameter file. So for example, I will open configuration A-scan. And so in this parameter file, I create several gates, for example, 3 gate, name synchro, plus G and the first echo. And here you have the C-scan associated. I will select just one for the demonstration, for example, the transmission scan. It's directly generating with cartography. So it's coming. So in this part you have several I will say depth. So you can see here in yellow, green, and blue, and you can directly calculate the B scan. So here is coming. So you have some slider, and when you move your slider, the B scan here is directly updating. So you can have B scan in this side or also in the other side. And it's also updating when you move your slider. And each cartography, A scan, B scan, and C scan are connected. So when I move my cursor, the A scan is also updated. And the other B scan is you can create a customized B scan. So for example, I go in my C scan, I create some slider here, and a new B scan is creating. So keep in mind you can have all the B scan you want in your part. So now I will show you some other feature, what we call a qual echo filter. So it's coming. So you have your C scan with some defect and with some trial. So I will create, I will remove the back wall echo. Can be interesting from some specific control. So at first you need to create an area. So here with this option I can select all my cartography and make the back wall echo filter. So you need to specify you use the local thickness variation threshold. For example, here I will put 1 microsecond. And when I apply the algorithm, all my back wall echo is filtering. So with this option, you can highlight your defect. So here, for example. So now I will go on another feature, what we call the CAD. So you can create a CAD fitting or load it. Is coming in another window. So you can manage with 3D part. So we'll import some CAD file. So you have your 3D part. You can move it, zoom on the part, etc. And also change the position. You can here open an image. So it's coming in the bottom. And I will manage some CAD fitting. So you can load some point directly on your cartography and compute and apply a texture. So coming, so directly the image in the bottom is directly applied in the 3D part. So with this feature you can put your C-scan directly on your part, and so you have a better idea of where the defects are or where is my C-scan on my part. So close this one, and I'm going to show you some automation. So in ULTIS, all the feature here you can make it manually, but there is also the option to do it automatically to saving time and avoid some error of the human factor. So I will directly start on automation. So it's work like a sequencer. So you specify in each step which feature you want to do. So at first, for example, I will load the C-scan, load the palette, make an edge detection, then a defect detection, and at the end create a report. So I will launch it. Sorry. So at first he asked me to select what C-scan I want to load. So for example, I will load this C-scan. So it's automatically open. It's automatically apply a palette. Here I specify a read palette. And there are two options. In the sequencer, you can do it full automatically with these buttons. For example, for the C-scan, I do it full automatically. And you can also do a semi-automatic sequencer. So here, for example, I make this button deleted and to say to the user to do it manually. So for example, I load the palette, I can, I don't know, for example, compress it, move it, etc. And then when I'm okay with this function, I say, okay, I validate. And then everything is do it automatically. So you make my edge detection. So here you can see the limit of your part. Then it creates some defect detection. So in the C-scan, all the defects around the drill are highlighted. And at the end, you have your the defect detection table with all the defects, with the surfaces, the position, etc. So, and with this table, you can have, I think, 27 options. So you can describe your defect with many options. So when it's done, at the end, you can create a report. So I will open it in my second screen. So for example, here in the report, I just say to export the defect table in the docx file. Keep in mind, you can also manage report with Excel file if you want. And the last option is you can also create some customized reports. So if you have some template in your company, for example, for Airbus, we have some template, and you can export all your post-processing from Ultis in your template with screenshot and all the manual feature I present you previously. So now I will skip on NDTkit RT. So there are also many other features. So if you have a question at the end, you can ask it and I will show you. Okay. So just a few seconds, it's open. So it's come NDTkit RT. So it's a NDTkit RT and Ultis and NDTkit they have the same kernel. So many features are import from Ultis. For example, for all the selections, the palette, the defect detection, automation, etc. So I will just present you the specific feature of NDTkit RT for the radiography. So I will open some radio. So open this thing. So we have an image with a gray value. So you can, with your mouse, you can change the contrast and the luminosity. So you can change it directly on the palette. And there are also some options to automatically perform I would say optimize contrast. So for example, I will create some selection. And you can specify with this feature to optimize the contrast inside this selection. So, and when you move your selection, the contrast is directly changing. Some other feature we open. So in radiography, sometimes you want to load a specific palette to highlight the defect. So for example, I will load a palette, the red palette, and you can contrast it. And when you slide from your palette, you can highlight your defect. So another feature, sometimes you want to make some measurement. So it's possible also with NDTkit RT. For example, in this defect, I will try to measure it with UT. So you can make some angle or directly some line. So here you can see my measurement is in pixel, but there are some ruler in NDTkit RT to connect the real measurement with the pixel. So I will do it. What we call scale ruler. So for example, I will say, okay, this little part, I don't know, for example, it's 5 millimeters. So I will say okay. And directly all my measurement here, there was in pixel and now they are directly converted into a millimeter. So if you know a small side of your part, for example, here it's like 5 millimeter, you can have the measurement of all your part directly with real measurement. So now we'll create some profile curve, so what we call ecodynamic curve. We can create in the both side, and when you move your cursor, it's directly updating here. So you have your gray value and also your pixels. So you can make some measurement with these two sliders. For example, to measure some bone. For example, here. So when I move my cursor, for example, here you have your part, and if you go in the circle, you can see it's directly shown here. So you can measure it and report it. And it's the same thing in the other part. And keep in mind, you can also manage specific slider. So if I want to do it like this, it's also possible. So for all the other features I already presented on ULTIS, I can show you the IQI checking. So I don't have the part on my computer, but I will show you the video to show you the IQI checking. So sometime in radiography you want to make some control to see the resolution of your cartography. So in NDTkit RT you can create a mask of your IQE. So here is a triple wire. So you specify the number of wire per series you have. So here you have 3. And directly the mask it's applied on your part. And you can control here each wires. And so if you, in the red, you have the wires that are not in your specification, and in green, the wires in your specification. So with this option, you can control the resolution power of your cartography. So I think I have no time now, Matthew. I think I presented all main features.
Yeah, that's really good. Thank you very much, Sophia. And just to reiterate that the automatic sort of process for the defect recognition is exactly the same as in ULTIS as well, isn't it?
Of course, yeah.
Yes. So it's exactly the same. So no, thank you very much, Sophia. I thought that was extremely interesting. Okay, I'll take back being presenter now. Okay, we can see the presentation.
Yep.
Yeah. Okay. So to follow on from Sophia's excellent demo there, Testia have very recently, within this week, just brought to market some some low cost scanning solutions titled the Smart Scanner. The idea being is that it's a simple and robust multi-method scanning system. At the moment, it's going to be used for ultrasonic and eddy current as well, but in this for this presentation, the ultrasonics would be most interested. And this works with our phased array offering, the Smart U32, but can also work with other technologies on the market as well. It is currently specifically tailored for the aerospace industry, but we will be more than happy to work with people if you have something a little bit more specific. And it's going to be off the shelf. It will be available in 4 sizes. So a scanning area of 0.6 meters squared, 0.98 meters squared, 1 meter squared, and 1.2 meters squared. But again, for specific geometries, we will be happy to develop something with our customers. So if we come back to features and tech specs, so for the ultrasonics, automated defect detection, measurement, and reporting, it's a completely configurable and customizable tool thanks to the plugin system. Defect detection, sizing, location, and grouping and porosity characterization. Reports can be stored and easily shared, and more importantly, repeatability of the analysis procedure is key. So it's a system that was developed for aerospace, but will very adequately operate within other industries like marine, composite, and manufacturing. Similar for radiography. It's automation of processes for high condensance work, image display optimization, profile curves, IQI checking, and it is ultra configurable. Programmable algorithms for reporting and customizable with Python and Java computer languages. Reports, again, direct read across from the UT are easily stored and shared, and repeatability of the analysis procedure. And again, was conceived for aerospace, but more than capable for working within marine, composite, and manufacturing. So last but one slide here. To summarize, since the year 2000, Testia with the Airbus group have been innovating and automating UT and RT inspection. The sole goal and focus of both software is to increase efficiency by speeding up workflow throughput and reach higher inspection volumes. Flexibility is key, very adaptable software, and increased reactivity by editing custom tools with Python and Java. That is only for the RT version. Traceability, full traceability, and reliability. It's repetitive and maintains the quality of results with minimal effort. To conclude, the NDTkit product range is the only automated defect recognition software that works with multiple manufacturers. Efficiency is increased, work volume throughput is increased, inspectors' capabilities and reactivity is increased. Taking away a fully qualified inspector from repetitive work allows them to put their skills and expertise to more detailed and refined work. Reports are easily shared and configurable to your needs and company identity, more importantly. And it's either, and we can have it via a dongle, which allows for added security. Full technical support is available from Testia, from the product team. Okay, so NDTkit, start of an investment. It's an evolving tool, so new features are added year on year, and we will also be more than happy to discuss specific features that you would need as well. and you're buying for the future. Thank you very much for joining. We'll take a moment to answer a few questions, if that's okay. So we have. Sorry, yes. So we were asked about pricing. So yes, pricing is on an individual license, but if it's to be networked, then we can discuss pricing on a networked system itself. What files? Sophia, this one's for yourself. We are just about to come out of time, but what file storage is used for RT? Is it DICON, Sophia?
Yes, you can import and post-process DICON-D and also all the image file like PNG, JPEG, TIFF, etc. So if you have your cartography with DICON-D, it's possible to deal with it with NDTkit RT, of course.
Lovely. Are there any other file storages that we should consider or we should talk about, or is DICON-D the most popular?
Yeah, the most popular for radiography is DICON-D and all the image formats. So, and for UT, it's what you show previously, all the format from, for example, Olympus, G, Dr. Egalza. I think there is like 40 format from company.
Okay, right. Sorry, yes, I do believe. Yeah, there was sorry, somebody's just said that there was a bit of a strange with the time starting. Yes, no, it was 10 a.m. this morning. Sorry for any confusion that was caused. So, okay, right. Thank you everybody for joining. Sophia, thank you very much for your time. We are now officially out of time. So. We are happy to send the presentation out. Please get in touch with us, and if you want to have a more specific demonstration, either get in touch with myself or Safir, and we can also organise trial licenses for you as well. So thank you very much, and I look forward to seeing you next time.